Hello everyone, welcome back for another video. So in this video, we're going to study how to evaluate functions. So let's start doing that. Take a look at this example. We want to find g of x at a given x values. So for the first one, we want to evaluate g of -2. So for g of -2, we're going to input -2 into g everywhere there is an x. So -2 is the new input. So we have, so instead of writing x, I'm going to write it as parentheses. So we have x squared minus 3x minus 1, and we'll replace x with this new input, which is -2. So we have -2 squared minus 3 times -2 minus 1. So that's how you evaluate function at any given x value. Now the rest is just doing the computation. So we have -2 squared, which is 4, -3 minus 2, that's plus 6 minus 1. So now you just combine them. So this would be 9. So g of -2 is 9. Let's take a look at the next one. We want to evaluate what is g of 2. So the idea is the same. We're going to rewrite x just using parentheses and leaving it blank. So we have x squared minus 3 times x minus 1. And then now I'm going to replace the blank with the new input, which is 2 in this case. So we have 2 squared minus 3 times 2 minus 1. And then the rest, we just evaluate what that come out to be. So 2 squared, that's 4, minus 3 times 2, that's 6, minus 1. And then we combine them, so we have 4 minus 7, and that would give us -3. So g of 2 is -3. Now for the last one, we'll do the same thing. Now we're going to input 1/3 in place of x for the function g. So g of 1/3, it's going to be again x squared minus 3 times x minus 1. And again, I'm going to replace x with this new input. That's 1/3 minus 3 times 1/3. And then we evaluate them. So we have 1/3 squared, which gives us 1/9 minus 3 times 1/3, that's 1 minus 1. So that would just be 1/9 minus 2. And then to combine these two numbers, we need common denominators, which happens to be 9. So I'm going to multiply -2 with 9/9. So that will give us 18. So we have 1 minus 18/9, which will come out to be -17/9. So that's our function value at 1/3. Let's take a look at another example. So take a look at this one. Now we have a different function and we want to evaluate at 0, 12, and -3. So let's do the same thing. So we'll plug in these different function values, different x values into this function. So for f of 0, we're going to insert 0 into x. So we have 0/0 plus 3, which will give us 0/3. That's simply 0. So f of 0 is 0. Now let's plug in 12. F of 12 is going to be 12/12 plus 3, which will come out to be 12/, and then 12 plus 3, that's 15 on the bottom. And then of course we can simplify this. So we have, so I can simplify them by a factor of 3. So on top we have a 4, because 4 times 3 is 12. And on the bottom we have 5, because 5 times 3 is 15, and the 3 cancels out with the top factor. So this simplifies to 4/5. And the last one, let's do f of -3. So we'll do the same thing, plug in -3 everywhere there is an x. So we have -3/3 plus 3, which will give us -3/0. So we have 0 on the bottom, which means when you evaluate this function at -3, it's undefined. So that means f of negative 3 actually does not exist. So we'll say this is an undefined value. Okay, because this can happen. All right, so hopefully this is helpful. Let's continue and do a couple more examples. Now take a look at this one. This one is slightly different from the previous two because now we want to evaluate f of 2 plus x, which means you're not just inserting a number into the function, you're inserting an expression. So, but the idea is the same. So now think of that as a one term. So we want 1 minus 3 times x, putting parentheses, minus x squared. And I'm going to replace x now with this new input, which is 2 plus x. So we have 2 plus x for the first x, and then for the second x that appear in the function, we again replace it with 2 plus x. So that's the setup. Now let's go ahead and simplify this. So we have 1, and for the first parentheses, we're going to distribute negative 3. So that'll be negative 6 minus 3x. For the second one, we're going to expand that. So we have minus 4 plus 4x plus x squared. So that's what we get when we expand 2 plus x squared. And then the next step, we want to distribute this negative out and then combine like terms. I can go ahead and combine 1 and negative 6, which is negative 5. And I still have negative 3x. Distribute the negative 1. We have negative 4 minus 4x minus x squared. And finally, we want to combine like terms again. So we have negative 5 and negative 4, that's negative 9. Negative 3x and negative 4x, that's negative 7x. And x squared doesn't have a like term, so that will just be negative x squared. And there are no more like terms, so that will be the final result of this expression. So you see how you can evaluate a function at an expression as well. So it doesn't always have to be a number. Let's take a look at another one. So here, I want to evaluate this function at these given expressions. So first we want to find what is f of a. Well, the idea is the same. Again, we're going to substitute a everywhere there is an x in the function. So we have 2 minus 4x squared. So x will be replaced with a squared. And then if you simplify that, that's just 2 minus 4a squared. And there are no more like terms, so we'll claim that's the answer for f of a. Now let's do the next one, f of a plus h. So again, we'll do the same thing. We're going to replace a plus h because that's our new input for x. So that will give us 2 minus 4 times a plus h squared. Now here, a plus h squared, we have to expand that before we distribute the 4. So we have 2 minus 4 times a squared plus 2ah plus h squared. And now we can freely distribute the negative 4. So that will give us 2 minus 4a squared minus 8ah minus 4h squared. And there are no more like terms, so we'll claim that as our result for f of a plus h. And now for the last one, we want to evaluate what is f of x plus h. Again, that's another input. We're going to replace an x to find what is that function value. So we're going to do the same thing, 2 minus 4 times x squared. Well, x is now replaced with x plus h. Okay, so that's the new input. Now again, you're going to expand it just like we did for the previous part and combine like terms. So we have 2 minus 4 times x squared plus 2xh plus h squared. Now we can distribute negative 4. So that will give us 2 minus 4x squared minus 8xh minus 4h squared. And again, you can see there are no like terms, so we'll claim that to be our final result for the expression f of x plus h. All right, So let's take a look at one last example. So for this example, we're going to evaluate a piecewise function. So sometime when you're evaluating functions, so you're not just evaluating one function, you could be evaluating a piecewise function where you have different pieces of functions in different interval. For example, this one, we have f of x is going to be x squared whenever x is less than -1. And we will have f of x equals x minus 5 whenever x is greater than or equal to -1. Let's evaluate the following. So to evaluate f of -3, so our input is -3. So that means I need to see which interval does -3 fits into. Well, I know -3 is less than -1. So that means I have to pick the top function of this piecewise. So I'll pick x squared. So I'll have x squared. Well, x is replaced with -3. So, and then we evaluate. So that will give us 9. So f of -3 is 9. Similarly, for f of 0, again, we pick which interval is 0 is in. So 0 is greater than -1. So that means we have to pick the second function. So we're going to pick x minus 5 to evaluate that. So we plug in 0 into x. We have 0 minus 5, which is -5. Let's continue to the next one. F of -1. Well, -1 fits into, again, the second function because the second one exists when x is greater than or equal to. So we will again pick the second function. So we have x, which is -1 minus 5, the result, -6. And then for f of -10, again, we decide which function to choose. -10 is less than -1. So we're going to pick the top function. So that would be -10 squared, which would be 100. And last one, f of 12. So we know 12 is greater than -1. So we'll pick the bottom function. So we have x, which is 12 minus 5 is equal to. So now here, I'm going to subtract them. That will give me 7. And that will be my final result. So I hope this video was helpful for you guys. Thanks.